I'm going to briefly explain how to think about integration in the complex plane. But first I'm going to talk about how we think of integration in the real numbers as a comparison. So from calculus, right, we have a set of axes, and we have some sort of a graph. And what we do is we normally kind of set off a couple limits of integration, and we just might want to find the area underneath the curve from right here. So we might call this A and this B, and we're just going to integrate over this interval right here. Now I want to focus on just a portion of this picture, because really what I'm going to be concerned about here are just the inputs. So I just want to look at the x-axis. Now in the analogous thing here, right, in my picture I chose to integrate from A to B. Now I could have chosen to integrate elsewhere. I could have chosen to integrate, for instance, from, I don't know, from C to D over here. But the point is, I have all these possible places where I can integrate. I need to choose just some small portion of them, some small one-dimensional portion of them, and then I integrate using Calc 1 methods. Okay, now take this idea. We're just going to look at the inputs now, and let's take this over to the complex plane. The complex plane looks like this. And remember, these are the inputs, so this picture is analogous to this picture down here. It is not analogous to over here. Here you have inputs and outputs. These are just the inputs of a complex function. The outputs of a complex function are also two-dimensional. If you want to put them together, I invite you to visualize it in your head, because it's going to be a four-dimensional object, and I cannot draw that here. So what do we have? We have inputs, and what I need to do is I need to select some sort of a one-dimensional section for an output. So this might be as simple as choosing A to B right there. Now keep in mind that the graph is not up here someplace. The graph is up in two different dimensions. So you can't actually see the graph from this picture, right? This is analogous to here. But I have other options. I didn't just have to choose an interval on the real line. I could have chosen something like maybe this interval. That's a one-dimensional. I could have integrated along there, because now I'm not limited to just the line. I have a plane where I can maybe string out and make the one-dimensional object curvy. Or I could do something like this. I could take this and I could integrate along a loop that closes back on itself, which is impossible to do here because you can never have a one-dimensional thing that loops back on itself. Or I could do something very similar. I could take this and I could integrate the same picture, and I could go in the other direction. So there's an analogy here. All right, when I integrate here, I normally go from left to right. I could integrate from right to left, and I just introduce a negative sign. The same thing is going to happen here. If I can figure out this green integral, the light blue integral here is going to be just the negative of it. So that's how you think of integration on C, right? We integrate over one-dimensional surfaces, right here. And so what do one-dimensional things look like here? Well, they might be along the axis. They might not be. I might have just some sort of a plane line outside of the axis. I can integrate over any of these shapes, and we will be integrating over that. That's the basic idea of how we can, why we're talking about these contour integrals when we integrate in